In this video, we're going to do a quick review of how to name and write formulas for ionic compounds. But before we do that, I want to remind you of the charges of the various elements on the periodic table. Remember, everything in the first column or the first group has a charge of +1. Moving across to the right, we have +2, +3, plus or -4. Then we go to the negatives, -3, -2, -1, and 0. Remember this section right here in the middle of the periodic table? These are called the transition metals. They have a variable charge, so we have to indicate the charge using a Roman numeral. So use a Roman numeral for the charge. There are 4 other elements that also need a Roman numeral when you're indicating the charge. They are not technically transition metals, but they are important because they do have a charge that can change, so they need a Roman numerals. That would be these 4 right here: tin, antimony, lead, and bismuth. So that block of 4 need a Roman numeral. So I'll just put a Roman numeral next to them. Hopefully you already have this written on your periodic table. If you don't, I would advise that you get all this information on your periodic table so that you have it in order to do the problems. The other thing I want to remind you is that anything with a positive charge, these are called cations. These are our positive charges, and anions are anything that has a negative charge, because that's going to be important in the rules when we write formulas and name them. The cation always comes first, followed by the anion. So let's look at some examples. The first 5 say write the formula for the following compounds. You can write these down on a separate sheet of paper or do them on scratch paper, up to you, but it would be a good idea for you to try these. So the first one is barium nitride. Look at the endings. The endings are very important. When you see this IDE, this means it's an element from the periodic table. So now it's an ion from the periodic table because it has an IDE ending. No element ends in IDE, but when we turn the element into an ion, it does. So nitride, this comes from nitrogen. So we have an N. Now we have to figure out the charge because it's not neutral. Nitrogen is neutral. Nitride is not. So we look, well, here is nitrogen. It's in the -3 column. So the nitride is N minus 3. We look for barium on our periodic table. Here's barium right here. It's in the second column. It's in the +2s. So this is barium has a +2 charge. Remember, all ionic compounds start with a cation. So that would be the barium +2 and end with an anion N minus 3. We need the charge to balance out to 0 because all compounds have an overall charge of 0. So barium nitride has a +2 and a -3. Well, that doesn't add up to 0. If I say +2 minus 3, that gives me -1. So that cannot be the compound. So we're going to think, what's the least common multiple between 2 and 3? In other words, what's the smallest number that 2 and 3 both go into? That would be 6. So what we want to get is a +6 charge and a -6 charge, which would add up to 0. So what do we have to multiply 2 by to get 6? Well, that would be 3. So we need 3 bariums. Remember, to show the amount of bariums or any element, you put a subscript. So a lower little 3 here. Nitride, well, what are we going to multiply -3 by to get -6? Well, -3 times 2 is -6. So we'd have N2. So that's barium nitride. Look at the next one. Very similar, but a little different. Barium nitrate. So this ending is not an element from the periodic table that has turned into an ion. This ending indicates a polyatomic ion. So you have to know your polyatomic ions. Remember, they're also on the back of your periodic table if you haven't memorized them yet. So nitrate is a polyatomic ion. We still have the cation of barium, which is still Ba +2, but nitrate is NO3 minus 1. So it's nitrogen with 3 oxygens all together with a -1 charge. This acts as one total unit or an anion. So we got our cation, barium ions, and then anion nitrate. So we have +2 minus 1. Again, that doesn't add up to 0. So what we're going to need is to find the least common multiple between 2 and 1. That's 2. So we want a charge of +2 and a charge of -2 to equal 0. Well, barium already has the +2, so we're going to need 1 barium. Remember, we do not write subscripts of 1, but nitrate, what are we going to multiply that negative? Remember, that also means -1. What do we need to multiply that by to get a -2? Well, that would be a 2 because -1 times 2 is -2. So we need 2 nitrates. Remember, if you need more than one polyatomic ion, you must put it in parentheses. So we have parentheses, NO3, that's our nitrate, and we need 2 of them, so we put a 2 outside the parentheses. Don't forget the parentheses. And again, you have to put the whole entire thing NO3 because NO3 is nitrate and you want 2 of those, so the 2 outside the parentheses. Okay, let's try another one. Lithium chloride. So I find lithium on my periodic table. Here it is, +1. So lithium is +1. Chloride. If I know my ions, chloride is ClO2 -1. So we have +1, -1. Well, those charges cancel out. I do have a polyatomic ion of chloride, but since I only need one of them, then I do not need parentheses. So it's just LiClO2. And again, this has an "ite" ending. That tells me it's a polyatomic ion. So it's not off the periodic table. I have to know my ions. So here's our answer, Cl or ClIClO2. No parentheses in this one. Okay, so I would suggest that you try the next couple and then check back in with me. So this one has a Roman numeral of 2. That's because manganese, if I look at the periodic table, here's manganese right here. It's one of those transition metals. Remember, they're always going to have a Roman numeral with them, and the Roman numeral is always positive because it's a metal. So I have Mn plus 2 phosphate. Again, that tells me it's a polyatomic ion. So I either look at the back of my periodic table or I've got it memorized, and that would be PO4 -3. So what do I need to get a multiple of 2 and 3? That would be 6. So I want 2 manganese. So I'm sorry, not 2, 3 manganese, Mn3, and 2 phosphates. Do I need parentheses around phosphate? The answer is yes, I do, because it's a polyatomic ion and I want more than one of them. So I need PO4 and I have 2 of them. So Mn3 parentheses PO4 parentheses 2. Last one, aluminum hydroxide. Students always say, well, aluminum needs a Roman numeral. No, it doesn't, because aluminum is right here. It's in the +3 column, right? So there's the charge, +3, aluminum is underneath that. So aluminum is Al +3 hydroxide. I know this ends in IDE, but there is no element like there isn't something called hydroxygen. So hydroxide, you should recognize that name as a polyatomic ion. That's why we had you memorize them. So hydroxide is OH -1. So thinking about that, we know the charges don't cancel, so we're going to make that Al, we need 1 aluminum and 3 hydroxides. Another common mistake is students will write this, OH3. That's wrong because you did not use parentheses. This is saying you want, the way this is written is you have 1 oxygen and 3 hydrogens. That's not what you want. You want 3 hydroxides. So to fix this, we would have Al parentheses OH, close your parentheses, 3. When I write it like that, this is saying I have 3 OHs. Or in other words, another way of thinking about it would be I have 3 oxygens and 3 hydrogens. Notice how that is different than 1 oxygen and 3 hydrogens. Here I have 3 and 3. So make sure you're very careful with hydroxide and using parentheses correctly. So you got to have the parentheses there. All right, let's go backwards. What if I give you the formula and you have to name it? So copper is Cu, and if I look for copper, I'm always going to check my periodic table. Well, that's atomic number 29 right here, transition metal. So that tells me I have to have a Roman numeral. So when I go to do this, I don't know the charge of copper, so I'm going to put an X above it. Oxygen. Well, in this case, it's going to be oxide because it's in a ionic compound, a metal with a nonmetal or a cation with an anion. Well, here's oxygen. I know its charge is -2. you will always know the charge of the anion. So that's -2. So we're going to kind of write an equation. So how many coppers do we have? We have one copper, so that's 1x, plus how many oxygens? We have one with a charge of a -2, and all compounds have a charge of 0. So if I simplify this, I have x minus 2 equals 0, so x equals 2. This is the charge of copper. In other words, that's my Roman numeral. So i.e., the Roman numeral on copper. So this would be copper, Roman numeral 2, and then oxide, because it's going to have the IDE ending since the anion is part of a ionic compound. So copper 2 oxide. For Roman numerals, you have to write Roman numerals from 1 all the way up to 4, maybe 5, but 4 would probably be the highest one you see. So let me show you this one more time. I remind you, how did I get this formula? You are going to take the number of cations, that would be the subscript. So look at the subscript. There isn't a subscript written here, but we know it's a 1, times the charge of the cation, which is going to be an x because we don't know its charge, plus the number of the anion. So again, look at the subscript. So here you're going to look at subscript. Remember the subscript's the little number. Here you're going to look at the subscript. And then you're going to multiply the number of anions times the charge of the anion. It's going to be a negative, right? So this is going to be a positive number here. This will be a negative number. And it's a compound, so it has to add up to 0. So you will be solving for this x. And eventually some of you are going to be able to do it in your head, and that's great. Okay, the next one, MgCO3. So if I look at magnesium, Mg, that's right here. Does it need a Roman numeral? The answer is no. It's in the +2 column. It's not a transition metal or one of these four. So we don't need a Roman numeral. So I don't write anything down. If you do, it's wrong. So I have my cation first. We always, whether we're writing formulas or naming compounds, cation always comes first. Think about it. Why would it come first? Well, the cations are on the left side. Those are your metals. And then the anions are on the right side of the staircase. So it reads just like the periodic table. You start with the cations and we move to the anions. So if you ever forget, you can just think about the charges and how they're arranged on the periodic table. So Mg is magnesium. And we said we do not need a Roman numeral because magnesium always is a +2 charge. Now this you have to recognize, CO3. Well, that would be, again, if you don't recognize it, you can look at the back of your polyatomic ion sheet. This is magnesium carbonate. Whenever you have more than 2 elements, you know you have a polyatomic ion. So when you see multiple elements, check for polyatomic ion. You've got to identify it. You don't have any polyatomic ions that have magnesium in them, so you know that the magnesium is just by itself. So you don't have Mg ever by itself. Uh-oh, what has happened? Hang on. So you have no magnesium by itself, no magnesium, I should say, in a polyatomic ion. So you know that the CO3 is a polyatomic ion. All right, let's try the next one. Wow, there's 4 elements. That's a lot. So let's think, is there a polyatomic ion here? The answer is yes, there's 2. So you should be able to identify NH4 and SO3. And this little 2 in the middle, that doesn't mean anything in terms of writing formulas. That's to say, or I'm sorry, in terms of naming, that 2 is just saying you have 2 ammoniums. So NH4, that's ammonium. And then SO3, you should recognize that as sulfite, I-T-E ending. All right, the fourth one, Na2S. So there's only 2 elements, so we know that there is not a polyatomic ion in here. So this guy has no polyatomic ion. It just has Nas and S's. So what would the ending be if there's not a polyatomic ion? The answer, the ending is going to be IDE because there's no polyatomic ion. So what's the name of Na and where is it on the periodic table? Well, Na is right here. That's sodium. It's in group 1. So the reason I checked where it's at is so I know the name, but also I know it doesn't need a Roman numeral. And then here's S. S is sulfur. So the sulfur turns to sulfide. So this is sodium sulfide. Notice IDE, ITE. You need to make sure that you write neatly. I can tell that's an ate ending, an ite, and an ide. If your teacher can't read your writing because you make it too messy, then it's going to be marked wrong. So make sure you're clear on that. All right, one more. We got AU, Cl, and O. So I know there's a polyatomic ion there. Okay, I can recognize ClO3 as my polyatomic ion. So if you know your polyatomic ions, you would know that this is chlorate. And then Au, well, if I'm looking at my periodic table, here's Au. That's gold. It's a transition metal. So what do transition metals need? Oh, they need a Roman numeral. So to figure this out, you have X for the Au, because we don't know the charge. Chlorate. If you know chlorate, you would know that as ClO3 minus. So that has a -1 charge. Now here's the tricky part. Remember, we said our formula right here is, I'm going to highlight it for you. Here's the formula. So we're going to plug everything in with this formula. So it says you're going to take the number of cations. That's Au. How many Aus do you have? Well, there's no subscript, so that's assumed it's 1. So we have 1 Au times its charge. Its charge is X, plus the number of anions. Well, how many chlorates do you have? Is the answer 3? The answer is no, it is not 3. There is only one chlorate. If there was more than one, you would have put it in parentheses. So we have one chlorate. Chlorate has a charge right here of -1. So times -1 equals 0. So we have X minus 1 equals 0. So X is 1. So the name of this is gold. Do I have to use a Roman numeral for 1? Yes, you do. You don't use a subscript of 1, but you do use Roman numerals. So this is gold 1 and then chlor 8. So you got to make sure you know your polyatomic ions, that you remember to use parentheses around polyatomic ions when you're writing formulas if you have more than one of them. And you have to make sure that you have Roman numerals for any transition metal plus these special 4. So this is a review of how to name and write formulas for ionic compounds.